All right, let's go ahead and get started. So starting our last chapter today, chapter 10. Chapter 10 is pretty much focused on functions. What functions are, how we can combine functions, and what the graphs of different functions look like. Now, you've no doubt come across functions before. Intuitively, what's a function? You've come across something that looks maybe something like this. F of x, oh, that's awful. It's equal to 2x.
Yeah.
Standard function, what is that saying?
Whatever.
So it's a rule for how you assign values. And so it's a pairing up of numbers. For every x, this is what we're pairing it up with. So when I plug 1 into this function, what comes out? 2. When I plug 2 into the function, what comes out? 4. When I plug 10 into the function, what comes out? 20. So it's a pairing off of numbers like this, and it's telling us how to pair up these numbers. Or, one way we think about it is it's assigning to this left-hand value this right-hand value. You're also used to writing a function, instead of using f of x, you're used to writing it as y equals 2x. And for every y is paired with double its x value. Pick an x, y is going to be double that value, you pair them up like this. So we think about a function as a rule for assigning to each number some value. So our functions are going to take as inputs any real number you want, and it's going to spit out some real number as a general rule. Good? How do we come up with the number that we spit out? So when I talk about what is f of 2, how do I figure out what f of 2 is? I replace all my x's with 2's. So this is 2 times 2, which is equal to 4. That's how I knew that when I plugged 2 into my function, 4 came out. Let me ask you a different question. If this is f of x, what is f of SpongeBob? It's equal to 2 SpongeBob. You just take whatever that x is, whatever I put here, replace all your x's with. If I say, what is f of a minus b plus c, that is equal to 2 times a minus b plus c. Whatever's here, replace all your x's with it. That's how you plug it to the function. Make sense?
Yes.
Okay. So first, let's get a sense for what these functions are. The rules are, for every number we put into the function, we can only get one number out. That's what makes it a function. You can't get 2 different numbers out. Otherwise, it's not a function. Okay. So let's look at some graphs really quick and determine which of these would be functions. So imagine I had some equation, could have been something like f of x is equal to x cubed minus 2x squared plus 17x minus 9. Something like that. And when you graph it, maybe it looks something like this. Some equation, here's some graph for some equation. Our question is this thing going to be a function? How do we know? There's one rule. Every input has to have one output. Every x value has to be paired with only one y value. And so we call it the vertical line test. If it passes the vertical line test, any vertical line you draw through it, if it only intersects the function at one point, we're good. It's a function. If it only intersects the graph at one point, we're good. It's a function. Here, this thing over here is not a function. Because this x value, let's see what the x value is. It's 1, 2, negative 3. So this x value of negative 3, what y value do you assign it? When x is negative 3, what's y?
0.
Is it this point up here, this height, or is it this height down here? Right? We're trying to assign to one x value 2 y values. It doesn't work. So this is a picture of something that is not a function. Yes? No. We call it the vertical line test. Every x value has to be assigned to one and only one y value. Otherwise, it's not a function. Make sense? So let's do some quick examples. This time, rather than giving you the picture, they're just going to give you the equation and ask you, is this a function? So is 3x squared minus y equals 5 a function? How do we figure that out? First off, let's solve for y. I'm going to move the y to the other side and the 5 over here. So I'm going to swap the y and the 5. So I get y is equal to negative 3x squared minus 5. Oh, positive 3 squared. Sorry, I was looking at the next line. So I took this and I just moved the y over here and the 5 over there. So the y is now positive, the 5 is now negative. That's how we got this.
Okay.
Now, for each x you choose, we only get one y value. If you give me an x squared is just one number. 3 times x squared, just one number. Subtract 5 is just one number. For every x you choose, we're only getting one y value. This is, in fact, a function. And if you were to plot this thing out, whatever it looks like, it'd be some sort of parabola-looking thing. It would look something like this, and it would pass our vertical line test. Every x value would have one and only one y value. Let's try another one. Let's see what happens when it's not a function. So, let's try this. Y squared minus x equals 5. Is this a function? First thing I'm going to do is move the x to the other side. So I get y squared is equal to x plus 5. Now I'm trying to solve for the y, so I got to take the square root of both sides. So over here we get y is equal to the square root of x plus 5. Remember, when you square root both sides, you have to do plus or minus.
So
Doesn't work.
it doesn't work because
So it doesn't work. If you pick an x value, we get 2 y values corresponding to that x value. So the picture of something like this would be like what we had up here. For a particular x, we're getting 2 y values out, a positive one and a negative one. So it's going to be some sort of picture that looks like this, which is not a function. So if you're getting 2 y values for a particular x value, it's not a function. If you're only getting 1 y value for each x value, it is a function. That's the test. That make sense? And you can either see that pictorially by drawing a vertical line if you're given a picture, or if you're given an equation, just solve for y. And see if for each x you get 1 y value. If you do, you're good. If you don't, if you get something like plus or minus, we're getting 2 y values for every x value, then it's not a function. All right. The domain of a function. So, I know we already introduced imaginary numbers and complex numbers in this class. For this section, put that out of your mind. All these functions are from the real numbers to the real numbers. Now, when you take a square root of a negative number, if I take the square root of negative 3, what do I get? Huh?
3.
Let's try square root of negative 9. What do I get?
I'm gonna say 9.
Can't.
What's the square root of 9?
You're saying
3.
The square root of 9 is 3, so what's the square root of negative 9?
Negative 3.
It's not negative 3, because what's negative 3 times negative 3?
is it
Positive 9.
Positive 9. So no, that doesn't work. It's 3i. I is not a real number. Thanks. We're missing Eva. I is not a real number. So it's an imaginary number. We did work with complex numbers. Now we're back in the context of just real numbers. Since this is not a real number, you cannot take the square root of a negative number and get a real number. So there's going to be 2 gotchas when it comes to evaluating the domain of a function. When we say a domain of a function, we're saying what x values can I plug in? So there's only 2 things you got to watch out for. You can't plug in x values. That makes like you're taking the square root of a negative number, because the square root of a negative number is not real. The other type of x value you can't plug in is an x value that makes you divide by 0. What's 3 divided by 0?
Can't. It's undefined.
It's undefined. It's not 0, it's undefined. Good? So those are the 2 things you can't do. Outside of that, you're good. So when they're asking you, what's the domain of a function? What are all the numbers I can plug in? It's going to be all the numbers that don't make you divide by 0 and that don't make you take the square root of negative numbers. Those are the only 2 things you have to watch out for. So let's do his concrete example now. So he has as his concrete example this one right here. He's saying our function f of x is equal to 3x minus 1 all over x squared plus x minus 6. So this is what our function is equal to. He wants to know the domain of the function. He wants to know what are all the numbers I can plug into this function and I don't break it. Notice that the only way we could possibly break this function is if we divide by 0. That's the only way this function gets broken, is if we divide by 0. So as long as we're not plugging in a value that makes our denominator 0, we're good. So what values make our denominator 0? In other words, when is x squared plus x minus 6 equal to 0?
the opposite of
Well, just factor it. So we're going to get x plus 3, x minus 2. So what values of x give me 0?
Negative 3.
-3 and
Two.
positive 2. So our domain is every number except these two. These are the only two numbers you can't plug into this function. If you plug in any other number, you'll get out a number. If you plug in -3, you're going to get 0 in your denominator, which is undefined. If you plug in 2, you're going to get 0 in your denominator, which is undefined. If you plug in 1, you're perfectly fine. It's just going to spit out a number. So when he asks for the domain of a function, he's asking what are all the numbers that you can plug into this function and we're still okay. So it's going to be all the numbers except -3 and 2. So our solution is all the numbers where x is not equal to -3 and x is not equal to 2. That's what that's saying. Any number except for -3 and 2 is good. These are the only numbers that break this function. Make sense? Let's try another example. So this time we got our function f of x is equal to 3x squared minus x. Are we ever dividing by a number? No. There's no division in it. So we don't have to worry about accidentally dividing by 0. Pick any x you want, we're not going to accidentally divide by 0. We may be multiplying by 0, that's perfectly fine. But there's no way that we can divide by 0 with this function. What's the other thing to watch for? Is there any numbers that we can plug in that would make us take the square root of a negative number? No, there's no square root symbol in there. So there are no numbers that break this function. Pick any x you want, you can plug it into here, and we'll spit something out. So the domain of this is all real numbers, which is what that symbol stands for. There are no bad numbers. Before there were 2 bad numbers in the example up here. This one, there are no bad numbers. Every number works. We're good. So you're looking for the bad numbers, the numbers that break the function. Those are the only ones that won't be in the domain. You can't break this function. Any number you choose, if you plug it in, you get a number out. Go ahead. Good? Let's try another one. Uh-oh, square root symbol. We should already be on our guard. What can't we do? We can't take the square root of a negative number and get a real number. So I can't have 2x minus 3 be negative. So 2x minus 3 has to always be greater than or equal to 0. Those are the only x values that will work here. Is where 2x minus 3 is greater than or equal to 0. When does that happen? That happens when 2x is greater than or equal to 3, or when x is greater than or equal to 3/2. So that's your domain. All the numbers greater than or equal to 3/2 work. You can plug those in. Any number less than 3/2 will not work. For example, let's plug in 0. Question, what is f of 0? Right up here. What is f of 0? In this case, that would be the square root of 0 minus 3, which is equal to the square root of -3, which is equal to, it's not a real number. 0 breaks the function. So we can't plug in 0. If I try plugging in 1, we get a similar problem. If I plug in 2, we're okay. If I plug in -2, we're in trouble. If I plug in any number greater than or equal to 3/2, we're okay. If I plug in any number less than 3/2, we're in trouble. We're going to be trying to take the square root of a negative number. So our domain in this case is going to be all x greater than or equal to 3/2. Make sense? All right. And then he just wants you to be able to plug into a function. Kind of already started out with this. But he gives you some function. Here's f of x. He says, now find f of -2. In other words, all he's saying is, do you know how to plug -2 into this function? How do you plug -2 into the function? Replace all your x's with -2. That's all there is to it. So doing that, we're going to have 3 times x squared, but we're replacing our x with -2. So 3 times -2 squared. Do yourself a favor, always put parentheses around the x when you plug it in. It'll help you not make mistakes with your signs. Then we have minus 4x. That's what we get when we plug -2 into the function. Now evaluate. What's -2 times -2?
4.
Positive 4. That's painful. Come on, guys. Negative 2 times negative 2 is 4. What's negative 2 times negative 4? Positive 8. So we got 3 times 4 plus 8. What's 3 times 4?
12.
Plus 8 is 20. And he better have 20. So f of negative 2 is equal to 20. Okay, that was the warm-up. No one's judging you on that one. You screw up this one, we're all judging you. So k of a is equal to 2 absolute value of a plus 4. Oh, that's scary. I only know how to work with k of x. You can't go around replacing x's with a's. It's too scary. It doesn't change anything. Exactly. So now when I substitute in, we just replace all our a's with whatever we're plugging in. So let's figure out k of negative 7. It's going to be 2 times the absolute value of a plus 4. Just like that, right? Negative 7 plus 4 is equal to negative 3. Absolute value of negative 3 is equal to 3. So this is 2 times 3 is 6. Still warming up. It's okay. So we get is equal to k of minus 7 equal to 6. Yay, we did it right. Okay, here he's trying to get really tricky with you. G of x is equal to x to the 4 plus 1. What is g of 3x? What do? We replace all our x's in here with 3x. So this is just going to be, so g of 3x then, is going to equal 3x to the 4 plus 1. Right? Right?
Yes.
Right?
Yes.
Someone yell no at me. No, why not? We have to replace all of our x's with 3 to the x's. This is why I tell you, do it with parentheses and you'll save yourself some headache. We replace that x with 3x, so it's 3x to the 4. Okay, and now that's going to be equal to 3 to the power 4 is 81. So it's going to be 81x to the 4 plus 1. Very different from 3x to the 4 plus 1. Okay. Oh, is that how you figured it out? Did you remember what 3 to the 4 was, or did you look at the answer?
It's just 3 times 3 times 3.
Okay, good. One more, but yeah. Let's make sure you can't see it this time. Scroll up a little bit though, because I think I have a little bit of glare. Okay. So let's look at this one. So we got p of t over here is equal to t squared minus t. Our job now is to find p of t plus 1. What do? I take all the t's and replace it with a t plus 1. Put parentheses so you don't mess yourself up. So this is equal to t plus 1 squared minus t plus 1. Put parentheses so you distribute that negative correctly. Now, just work it out. T plus 1 squared, you already know how to do this. That's going to be t squared plus 2t plus 1. And then distribute the minus to both those. Minus t minus 1. Combine like terms. How many t squared terms do I have? Just 1. How many t's do I have? I have 2 here and minus 1 here for a total of just 1 t. And then the 1 and negative 1 cancel out. Follow the algebra there? Go a little bit fast because we've done that kind of thinking a few times. So t squared plus t. Not as hard as that's going to get. So now you get to your exercises. First he's going to give you some pictures, ask you which of those are functions, and then give you some equations, and then have you plug in some numbers to some functions. Straightforward for the first section? All right, next section. Our function operations. How we combine functions together. We can do roughly 5 things here. So I guess he has it written out here, I don't need to write it up. How do we add 2 functions together? If I've got a function, move my mouse. If I've got a function f and a function g, then f plus g of x is just equal to f of x plus g of x. Good? So you just add the 2 functions together. That's how you get the sum of 2 functions. Difference, same thing. Product, same thing. Quotient, same thing. A little bit careful, you can't divide by 0. And then there's one more that he doesn't give us here, but that's composition. F composed with g, that's an open circle, kind of like the time symbol, of x, is equal to f of g of x. So you take this function and pass it into this function. Sounds a little scary, but pretty easy. So let's do some examples of this. So first off, here's two functions. F of x is this function, g of x is this function. He wants us to find f plus g of -3. There's two ways that you could do this. So the first way we can do this is we can figure out what f plus g of x is. This function by definition is f of x plus g of x, which is equal to, what's f of x? It's x squared minus 2x minus 2. X squared minus 2x minus 2. What's g of x? It's x plus 1. So we're going to do plus x plus 1. Combine it all together. How many x squares do we have? Just 1. How many x's do we have? -2 and +1 is -1. And then -2 plus 1 is -1. So here is f plus g of x. Now we can plug in -3 to this. And so f plus g of -3 is just equal to, plug -3 into there. It's equal to -3 squared minus -3, use your parentheses, -1. What do we get? -3 times -3 is 9, plus 3 is, -1 is 11. So we got 11. There's one way we could have done it. Let's just make sure really quick we got his same answer. He got 10. Uh-oh, what did we mess up? Let's go back to when that's in the way. Okay, let's see, what did we mess up? Why do I have a 2 there? Okay, that's what we messed up. Right? Here's f, here's g. So when we do all that, the x's go out, and we're left with just -1. Okay, now plug in the -3. And why am I doing a -1? It's a +1. Come on, guys. Oh, because that's a -2. Okay, we're right. So that's -3 squared minus 1 should be 8. He still has 10, doesn't he? All right, let's do it the second way and see if we're just doing something really dumb. Let's do it the second way to the side. The other way that we could do this is just evaluate this at -3, and then evaluate this at -3, and then take their sum. So let's evaluate this one at -3. So f at -3, what does that equal to? -3 squared is 9, plus 3 minus 2. This we evaluate at -3 is -3 plus 1 is -2. Add those together, and what do we got? We got 12 minus 3 is 10, minus 2 is 8. We still get 8. So he's the one with the mistake, not us. Oh, his solution isn't. Okay, so he does get it. So there's the two ways we could have done it. We could either figure out what f plus g is first, and then plug in -3, or we could have figured out f of -3, and then g of -3, and then added them together. Both perfectly valid. All right, let's move on to the next one. H and k, this time we're looking for their product. So h of x is equal to this, k of x is equal to this. What's h times k of 5? So we know that in general, h times k of x is just equal to, well, let's just go straight to solving it this time. So we're looking for h times k of 5. We know that this is equal to h of 5 times k of 5. So now let's figure out h of 5, let's figure out k of 5, and then take their product. What is h of 5? When I plug in 5 here, so we'll scribble it to the side over here. What is h of 5? It's what? 10x minus 4. It's just 10 minus 4. We're plugging in 5 for x. So it's just 10 minus 4, which is 6. So h of 5 is just 6. What is k of 5? Negative 14. Right? You got negative 15 plus 1 gives you negative 14. Okay, so now what are we doing? We're looking for the product of those two numbers. So we're looking for 6 times negative 14. What is that?
84.
Negative 84. Good. All right, let's see if that's what he got. Negative 84. Okay, it worked. Taking the difference, same process. Taking the quotient. We'll take the quotient really quick. So, f of x is equal to this, g of x is equal to this. Now he wants us to find f over g of x. So he didn't give us a particular number. So he wants it in general. Now, what is f over g of x? By definition, that is f of x over g of x. So that's what we're looking for. So it's just x squared minus 4x minus 5 all over x minus 5. Now we just need to simplify. Because potentially we can factor this and get something to cross cancel. So let's look in the top really quick. We're looking for two numbers. Multiply together, give us negative 5. Add together, give us negative 4. Since we can't cancel at the bottom, we already see it has to be minus 5, and so plus 1. Right?
Yeah.
And then x minus 5 cancels out top and bottom, and so we're left with x plus 1. So it turns out this divided by that is just equal to that. You could have also worked this out with synthetic division, the way you know and love. We would have gotten the same answer. So x plus 1. Okay. Here's a good other example. Here's f of x, here's g of x. The author wants us to find f plus g of x squared. So, by definition, f plus g of x squared is equal to f of x squared plus g of x squared. So we replace all our x's with x squareds in both these and add them together. So this is equal to f of x squared, replace all your x's with x squared. So that's 2x squared minus 1. Plus g, replace all your x's with x squared, that's just x squared plus 4. Good. 2 plus 1 is 3x squared. Negative 1 and 4 is plus 3. Just combining like terms.
Right, I'm saying the x squared plus x squared, isn't that x to the 4th?
No, that's x squared times x squared. Okay, so let's see what we get. 3x squared plus 3. Yay, got our answer. All right, multiplying, similar thing. Don't know if that's worth it. Here's where he introduces the definition of function composition. I already told you that. Sorry. Function composition. F composed with g of x is just equal to f of g of x. So now he's going to have us compose these two functions together. So a of x is equal to x squared minus 2x plus 1. B of x is equal to x minus 5. What is a composed with b of 3? By definition, this is equal to, so a composed with b of 3, by definition, is equal to a of b of 3. So first, let's find b of 3. What is b of 3? What do we get out of b when we plug 3 in? When I plug b in, what comes out? Or sorry, when I plug 3 in to b, what comes out? Negative 2. So b of 3 is negative 2. So b of 3 is the same thing as negative 2. So this is equal to a of negative 2. What do I get when I plug negative 2 in for a? Bit harder. Negative 2 times negative 2 is 4. We're going to have minus 2 times negative 2 is going to be the same thing as plus 4 again. You see that? And then plus 1, which is equal to 9. So the answer is 9. That's all there is to it. Plugging a function into a function, not as crazy as it seems. Pretty straightforward. You plug in the answer from one function as the input for the next function. All right, let's try it more in general, not with a concrete number. So this time he gives us our two functions f and g. We want to find f composed with g of x. How do we figure this out? The definition of f composed with g of x is equal to f of g of x. So what is g of x? It's just x plus 3. So this is equal to f of x plus 3. What is f of x plus 3? Replace all your x's with x plus 3. Use parentheses so you don't confuse yourself. Replace that x with x plus 3, and then it was squared, minus replace that x with x plus 3. Use your parentheses so you don't forget to distribute correctly. So this is equal to, we get x squared plus 6x plus 9, squaring that out, minus x minus 3. So it's all said and done. How many x squareds do we have? We have just one x squared. How many x's do we have? 6 minus 1 leaves us with 5 x's. How many constants do we have? 9 minus 3 leaves us with 6. Make sense? We just plugged g of x into f. That was g of x. We just plugged it into f. I replaced every x in f with g of x, namely x plus 3. And then just worked out the algebra. Came out with x squared plus 5x plus 6. See what he got? He also got x squared plus 5x plus 6. All right, let's do one more of these. Is that the last one? Okay, so we'll just do this one. Here's where he defines the functions, up top. So here's f of x, here's g of x. We're doing g composed with f of x. So g, this time we're doing g composed with f. Oh, I think we did it this way both times. So g composed with f of x, by definition, is equal to g of f of x. Exactly. We already know what f of x is. It is x squared minus x. That's what that equal sign means. F of x is identical with x squared minus x. So this is g of x squared minus x. So now we need to plug that in for every x in g. So this is equal to, plugging in for this x squared minus x, plug that in for x, and then we just have a plus 3. And so it's just equal to x squared minus x plus 3. X squared minus x plus 3. It's that easy. And, that's his solution. X squared minus x plus 3. Okay, so that's the second section. Just performing operations on functions. Our third section is on inverse functions. What's an inverse function? It's a function that undoes another function.
So it's what I'm talking about before.
So let's think for a second about this function, f of x equals x plus 5. If we were to give this function a name, it's a function that increments by 5. You give it a number, it spits out the number that is 5 bigger. You plug in 8, it spits out 12. You plug in 20, it spits out 25. Right? This is a function that spits out is 5 bigger. What would be the inverse of that? What's the opposite of adding 5 to a number? Subtracting it. So g of x equal to x minus 5 would be its inverse. This is a function that undoes this.
So can you get in this inverse, can you get a square root or not all?
You can never take square roots of negative numbers with these functions. You can never divide by 0. Okay, good. So now, let's see something cool about these functions. Give me a number to plug in for 17. Or give me a number to plug in for x. 17. I was going to plug it in, then decide I ask you guys. So notice, what is f of 17 equal to?
On the top? Oh, 21.
21. Almost.
22.
22. Right?
Yeah.
Now let's plug 22 in for g.
Oh.
And what do we get? Plug 22 in for g, what do we get? 17. Look, we took 17 and we added 5 to it.
Oh,
And then we put it in here where we subtract 5 from it.
I thought you were saying I feel like you're saying G, not F. I was just kidding.
F, okay, so I probably said it weird. Sorry. The point is, now look at this. What is G of F of 17? F of 17 is 22. So this is G of 22.
7.
What's G of 22? 17.
So whatever.
G of F of 17 is 17.
So whatever number.
So when you take some number, if you run it through its function and its inverse function, it spits out that same number. Take a number, if you run it through a function, and then you run it through its inverse function, you get back where you started. Notice this would have worked if we would have done the opposite way. I could have done F of G of 17. What is G of 17 equal to? What is G of 17 equal to? What's 17 minus 5? 12. So G of 17 is 12. Now it's F of 12. 17. And so when you take a number, if you run it through a function, and then you run it through its inverse function, you get back to where you started. So that's what we mean by the inverse function. It's a function that undoes whatever the first function did. Sometimes we represent the inverse function, rather than calling it g of x, sometimes we represent it as f with a minus 1 up there. This is not an exponent, it's a symbol. We're just saying this is the inverse of this function. Now, I gave you a pretty function where it was easy to figure out what its inverse was just from thinking about it. I could have given you a slightly harder function. Let's try one just slightly harder. I tell you f of x is equal to 2x. It's the function that doubles. What would its inverse function be?
2.
2?
Oh,
2x? It's the same?
no.
If this doubles, what's the opposite of doubling?
Dividing.
Halving. Cutting it in half. So its inverse function is going to be x over 2. Let's see. Pick a number.
6.
6. Run it through this function. What's f of 6? 12. What's f inverse of 12? 6. You get back where you started if you run through both these functions. Let's go the other way. Run 6 through here first. 3. Plug 3 into here. Back to where you started. So they are inverses of each other. Now we're going to teach you how to calculate inverses in general. So let me give you one slightly more complex that you might have had to think about for a second. We're going to call this one 2x plus 3. How do we come up with that one's inverse? Bit harder. You're probably not going to be able to get this one correctly just by sitting there thinking about it. So here's how we do it. Replace your f of x first off with a y. So this is the same thing as the function y equals 2x plus 3. You good?
Yeah.
Now I'm going to swap my y's and my x's. I'm going to say x is equal to 2y plus 3. Now I want to solve for y. So subtract 3 from both sides, and I get 2y is equal to x minus 3. Divide both sides by 2, and then we get y is equal to x minus 3 over 2. So finally, our inverse function, f inverse of x, is equal to x minus 3 over 2. And now I can say it in words, and you'd probably understand it. This is a function that doubled and then added 3. This is a function that first subtracts 3 and then cuts in half. So it undoes what this does. And notice that first this doubled, then added 3. So first this one has to minus 3 and then cut in half. It needs to do it in the backwards order. So that is a process where you can always calculate an inverse function. Just for kicks and giggles, let's make sure this works. Give me a number. 12. So let's figure out what f of 12 is. So forget these functions. What is f of 12? 24 plus 3 is 27. All right, now let's look at f inverse of 27. So we need to take 27 and subtract 3. What's 27 minus 3? 24. 24 divided by 2 is? 12. We're back where we started. Yay. It worked. Okay, so that is inverse functions. Now we'll see whatever the author says. Okay. So first off, the author gives you two functions, and he's going to ask you, are these functions inverses of each other? How do you know if a function, one function, is the inverse of another function? They have to undo each other. It has to be the case that if f and g are inverses of each other, then f of g of x has to just equal x. Whatever you get when you run it through both functions has to be what you started with. That's how you test it. You literally plug this into this and see if when it's all said and done, you're left with just x. So you're going to plug this into this, simplify, and you better be left with just x. If you are, they're inverses of each other. If you're not, they're not inverses of each other. So let's run through this one. So I'm going to plug, what are we calculating here? I'm going to calculate, we can do f of g of x or g of f of x. Doesn't matter which way we go. I'm going to calculate g of f of x here. And it better be, when we're all said and done, just x, where these aren't inverses of each other. So let's calculate it. So we're plugging in f of x into this function. So I need to replace my x with this whole thing. So I got my x, which is the cube root of 3x plus 4. We take all that, we cube it, we're going to minus 4 and then divide by 3. Right? Now, when you cube a cubic, those just cancel each other out. And we're left with just the inside. So this is equal to just 3x plus 4 minus 4 over 3. What's 4 minus 4? 0. So we're left with 3x over 3. Cancel out 3's top and bottom, and we're left with x over 0.
Which is undefined, which means it's not.
Right?
So it's not, right? It's not, it doesn't equal
1.
x. It equals nothing.
1! You're left with 1 when you cancel out top and bottom, not 0. Okay, and x over 1 is just x. Yay, it worked. So these are inverses of each other. Make sense? Okay. Another one of these, are these two functions inverses of each other? Just plug in one to the other and see if it works. In this case, what do we think? You think those are inverses of each other?
Yes.
Yes?
Yes.
Well, you're wrong. They would be if it was the whole thing over 2. So it's almost there, really close. So if we tried this one, it wouldn't quite work out. So let's do that really quick. Let's look at h of g of x. See what we get. So we're plugging in this for the x here. So we've got 2, plug in for our x, x over 2 minus 5 plus 5, which is equal to 2 times x halves is just x, 2 times negative 5 is negative 10 plus 5, which is then equal to x minus 5, which is not just x. So they're not inverses of each other. So don't just go based off of your intuition. You'll likely be wrong. Actually plug it in. And that's what that was meant to catch on. Okay. Are these two inverses of each other? Once again, plug in one to the other. And now he's taking you through the process of how you calculate the inverse function. I already took you through this. When you have your f of x is equal to x, first off, replace your f of x with the y, swap your y's and x's, solve for y, and then you got your inverse function. So I already took you through that process, but let's go through it with an example again. So here's the function he gives us. Make that just a little bit higher. So here's the function he gives us. Our job is to come up with the inverse function for this. Okay? So his function is this. Our job is to come up with the inverse. So first off, write it as y is equal to x plus 4 cubed minus 2. Okay, now what do? We swap our x's and our y's and then solve for y. And that will give us our inverse function. So swap our x's and y's, so we get x is equal to y plus 4 cubed minus 2. Okay, so now we're going to put the minus 2 over there. I'll continue writing right here. So I'm going to write y plus 4 cubed is equal to x minus 2.
Is
right?
that a plus? Because it's -2 already. So
Thank you. Good catch. Did I do anything else dumb?
No.
Okay. Now, take the cubed root of both sides. Over here, we're left with just y plus 4 is equal to the cubed root of x plus 2. Finally, subtract 4 from both sides. So y is equal to the cubed root of x plus 2 minus 4. And then finally, replace your y with the f inverse symbol. So our inverse function, f inverse of x, is just equal to the cubed root of x plus 2 minus 4. So that should be his answer. And there it is. Cool. So that's going through the process of calculating an inverse. He calculates an inverse again for another one. And that's it. So inverse functions. All right, last section is on exponential functions. What is an exponential function? It's a function where your variable is an exponent. So this is not an exponential function. F of x equals x cubed. It's not an exponential function just because you have an exponent in it. That is not what we mean by an exponential function. An exponential function will be something like f of x is equal to 3 to the x. When your variable is an exponent, then it's an exponential function. And so now we need to figure out how to solve some of these exponential functions. So here's our first example. We're trying to solve this equation. Notice that our variable is in the exponent. How on earth are we going to solve this thing? The trick to these is to get what we call a common base. Since this is 5 to the power of something, I need this to be 5 to the power of something. Now 5 to the power of what is 125? Power of 3. Good. So I now know that 5 to the 2x plus 1 is equal to 5 to the 3. Now look, if this whole number is equal to this whole number, then this exponent has to be equal to this exponent. You see that? So I get that 2x plus 1 has to equal 3. Or in other words, what does x have to be? You don't just see it? Okay, let's keep working with it. Subtract 1 from both sides, and we get 2x is equal to what? 2. Divide both sides by 2, and we get x is equal to?
1.
1. That's our solution. X equal to 1 is the number that makes this true.
Oh. Sorry. I was trying to figure out what you say first.
Okay, sorry. It's good to have an example. So we were looking for the x that makes this true. And notice that 1 makes it true. What's 2 times 1?
2.
Plus 1? 5 to the power of 3? 125. That's what we were after. The x that made that true. Make sense? All right. Let's try another one. Okay, so for this next one, we have 8 to the 3x. 8 to the 3x equal to 32. First thing we need to do is get these things in a common base. Right? What base, what number can I express these as exponents of? Is this gonna, can I represent this as a multiple of 8? Or as an 8 to the something?
No.
No. Because 8 to the 1 is 8. 8 squared is 64. So I can't get the common base can't be 8 for these two things. What number could it be?
Can't do 4.
You can't do 4 either. Because 4 and then we get 16. How about 2? So what is 8 when we use 2 as a base? It's 2 cubed. So here's our 8, and we have that to the 3x, is equal to, in terms of 2, what's this? 5. Good. That's 2 to the 5. Okay, so now we have a common base. Now remember our exponent rules. An exponent to an exponent, you just multiply them. So this is the same thing as 2 to the 9x is equal to 2 to the 5. Now, if 2 to the 9x is equal to 2 to the 5, 9x has to equal 5.
It's going to be negative.
So that's be negative 4.
So 9x is equal to 5. I don't know how you guys are getting negative numbers.
4.
Let's try this again. 9x is equal to 5.
Is 5.
So now this is a product.
So it's 9 subtract 5.
No.
So it's 5 minus.
5 nines. Divide both sides by 9. Right? Divide by 9, and we're left with x is equal to the 5 nines. That's our answer. And now, let's plug that into C. So we're looking at 8 to the power of 3x. So we're looking at 8 to the power of 3, and we're saying this is our answer, times 5 nines. The 3 cancels with the 3, top and bottom, so we're going to end up with 8 to the power of 5/3. How do I calculate 8 to the 5/3? We either do 8 to the 5, then take its cubed root, or you do 8, take its cubed root, then raise it to the power of 5. I mean, take its cubed root, then raise it to the power of 5. What's the cubed root of 8? The cubed root. What times what gives you 8?
Oh, 2.
2. The cubed root of 8 is 2. Square root of 8 doesn't have one. The cubed root of 8, 2. We're getting smaller numbers.
Oh.
So the cubed root of 8 is 2, and then 2, so then 2 to the power of 5 is
32.
32. So it worked. We found the x that made this true. Make sense? Okay. Let's try a tricky one. Here's a trickier one. So we have a 1/9 over here, and then we have a 3 over here. Now, if that was a 9, this would be real easy, because 9 is just 3 squared, and so our common base would be 3. What are we going to do with 1/9?
Rewrite it.
Yeah, we're going to rewrite it. We're going to rewrite it as, so 1/9 is the same thing as 1 over 3 squared, right? How do I get it in the numerator? What do we do to the exponent to flip it up?
Make it negative.
Make it negative. So this is equal to 3 to the negative 2. 1/9 is the same thing as 3 to the negative 2. Okay, so now I'm going to rewrite this with 3 to the negative 2. So now we're looking at 3 to the negative 2 to the 2x is equal to 3 to the 7x minus 1. When you have an exponent to an exponent, what do we do?
Combine.
How do we combine them? Do we add them? We multiply them. Good, we multiply. So multiplying those two together, we get 3 to the minus 4x is equal to 3 to the 7x minus 1. Now I have 3 to something is equal to 3 to the something. Those somethings have to be equal. And so their exponents have to be equal, so I get negative 4x has to equal 7x minus 1. Now, get all your x's on one side, your constants on the other side. So I'm going to pull all my x's over here, my constants over there. So add 4x to both sides and bring the 1 over. So the 1 over here becomes positive. Adding 4x to both sides gives us 11x. Or in other words, x is equal to 1/11. Make sense? And then, not going to try and plug that one back in. You can try it on your calculator, plug it into both those, see it gives you the same number. Okay, let's try another one. So we've got this one. I've got 5 to the 4x times 5 to the 2x minus 1 is equal to 5 to the 3x plus 11. When we multiply terms together, what do we do to their exponents? We add the exponents. When you multiply terms, you add exponents. So this is the same thing as 5 to the power of 4x plus 2x minus 1 is equal to 5 to the 3x plus 11.
Wouldn't it be 25 if you're adding the other 5?
3 times.
When we multiply terms together, we add their exponents. Let me give you, here, this will fix it in your head real quick. If I have 5 squared times 5 cubed, I have 5 to the 5.
Okay.
Okay. When you multiply terms, you add exponents. Okay, anyways, back to what we were saying. So I just added these two together, right? So now I have 5 to something equals 5 to something. Those somethings have to be equal. So this has to equal this. Now 4x plus 2x is the same thing as 6x. So 6x minus 1 has to equal 3x plus 11. Put all your constants on one side and all your variables on the other side. I'll put my x's on the left, constants on the right. So subtract 3x from both sides and add 1 to both sides. So I'm left with 3x is equal to 12, or x equals 4. So x equals 4 should be his answer, and can't see it under all my writing, but that is what he got. X equals 4. Okay. It gives you a bunch of rules. We already saw that trick. Is that the last one? Okay, we'll just do the last one, because why not?
Okay.
Let me scroll down, see if we can find some white space. Scribble. That's not bad. Okay, so let's do this one now. This one's got a lot going on. What is my common base going to be? Huh? 2. It's got to be 2. So express everything in terms of 2's. So what's 16 in terms of 2's? It's 2 to the power of what? 4. 2 to the 3 is 8.
Yeah.
So this is 2 to the 4. There's our 16, and we have 16 raised to the power of 2x minus 5. Okay.
That was just 2 to the power of
Times, what's 1/4? 2 to the power of what is 1/4? Negative 2. So this is times 2 to the negative 2, and then that's all to the power of 3x plus 1.
2 to the power of 5.
Oh, did I mess up? Oh, no, you're just going to the next one. That's 2 to the power of 5 times, what's 1/2? 2 to the power of what is 1/2? Just negative 1. It's just reciprocal of 2. So this is 2 to the negative 1, and then to the x plus 3. Now, when we multiply terms, first let's figure out the exponent too. So I'll write that down here. So I've got to multiply this exponent by this exponent. So that's going to be 2 to the 8x minus 20 times 2 to the minus 2. Good. Is equal to, over here, 2 to the 5 is still 2 to the 5, but then we have times 2 to the negative x minus 3. Right? Now, when we multiply terms, what do we do with the exponents? Add exponents. So this and this add together. So that's 2 to the power of, let's see, 8 minus 6 is 2x. Negative 20 minus 2 is negative 22. Is equal to, we have negative x, so it's going to be, we have negative x, and then 5 minus 3 just gives us plus 2. Okay, so now that we got all that, we're left with that 2x minus 22 has to equal negative x plus 2. All my x's on the left, constants on the right. So add x to both sides, and we're left with 3x is equal to, add 22 to both sides is 24, divide both sides by 3, and we get x equals 8. And there's our solution. Whooped. So there we go. It worked, and that is our last section of the day. We only have one more class ahead of this until we're done with the book. Any questions on that?
Is our finals in April or May?
Your final? Let's see. So we got next week. We have 4 more classes after this.
Next week the test on chapter.
Next week is you're finishing the material. Week after that is your second test for this semester. Week after that is your final.
So it's the 30th.
And then a week after that, we'll do a quick trig review.
So it's the last day, second last day.
So we're doing a test review or a test,
Third.
then a final?
We're just doing a test and a final. No review.
So
All the review is all the lectures that I have recorded. You get to go watch them again.
If we fail the final,
You failed the whole year.
it's not just.
And I'll even go back and give you F's on previous classes. So don't fail the final. Study hard. Let's not even worry about what happens if you fail the final.
What are you putting on? What materials are you putting on the final? Are you putting them in from first semester?
No. Oh, on the final?
Yeah.
I don't know. I haven't decided yet. Haven't written it.
Will you tell us when you do it, so we can know?
Can you tell us what
Here's what you need to know to be able to pass the final. You need to know intermediate algebra. The final is to ensure you learned intermediate algebra. That's the whole point. Make sure that this year wasn't a complete waste of time. That's the goal. So, any other questions? Now we need recorded.
take you to work? Our final test on certain-
Okay. Let's do